welcome back to my channel. Today we're gonna work on the question house robber. So you're a professional robber planning to rob houses along a street. Each house has a certain amount of money. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if 2 adjacent houses were broken into on the same night. So given integer nums representing the amount of money of each house, return the max amount of money you can rob tonight without alerting the police. So let's look at this question. Nums equals 1, 2, 3, 1, and if we rob house 1 and then house 3, 1 plus 3 equals 4, the total amount is 4. The alternative is robbing 2 and 1, which will give us 3, which is not the maximum amount of money we can get. Looking at example 2, if we rob house 2, 9, and 1, we get a total of 12, but if we rob house 7 and 3, we only get 10, so we rob 2, 9, and 1. Looking at this question, this is a classic dynamic programming question. How we know that is usually dynamic programming questions are asking for something such as the maximum amount of money or minimum amount of money, or how many total ways there are to do something. Those are common things we see in dynamic programming questions, and then usually dynamic programming questions have overlapping subproblems, and the problem has an optimal structure, and then we can find the state for each subproblem. And basically to solve it, we need to find a recursive relation between each state to transit to the other state. Today I'm going to solve this using dynamic programming top-down method, top-down optimized recursion. And like any recursion problem, I means index. So like any recursion problem, we should first find our base case. So the base case for this problem should be, if there's only one house, then we for sure just rob that one house. And if there's only 2 houses, then we have to check the maximum between 1 or 2. Return that one as our maximum profit. So let's write that in code. Our current state of robbing, basically. So if I equals 0, then we return nums 0. And if I equals 1, we return the maximum between nums 0 and nums 1. Recursion with memorization, we can have a memo dictionary to store our results so we don't repeat calculations to save up on time, or else if everything, like the Fibonacci sequence, everything keeps getting recalculated, our time complexity will be very high. It will be O to the 2 to the exponential of n. So we want to keep our time complexity O of n, basically just calculate everything once. So we check if I in memo, if I not in memo, then memo, we update it to our memo I as basically to the recurrence relation of this, of each state should be, we want to check if we're at house 3, whether we want to take house 3 and house 1, or we just take house 2. So we want to find the maximum between those 2. The max of dp I minus 1 or dp I minus 2 plus nums I. So nums I is our current number. Let's say we are at 3, and then we want to see if the maximum of 3 plus 1 equals 4 or is greater, or whether 2 is greater. That's what this relation is saying. And you want to return memo I if it's already calculated. And we need to put how many houses there are into sorry, I called it df, it should be dp, into our dynamic programming function. So you can do something like dp return dp length of nums minus 1. So this is how I would solve this question using dynamic programming, a top-down approach with recursion and memorization. The time complexity would be O of n since we only calculate each step once, and the maximum, looking for the maximum, is a O of 1 operation, so we don't count it towards our time complexity. The space is also O of n. We store as many, the length of the houses there are in our memo, and O of n is also the biggest our stack could go. So thank you so much for watching, and let me know if you have any questions.